Hello everyone, I'm Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. Today we will talk about Barton-Zard reaction. In Barton-Zard reaction, nitroalkene or vinyl sulfone react with α-cyanoester in the presence of base to produce pyrrole. But don't confuse with Barton Decarboxylation reaction in which carboxylic acid or acid halide converted into alkane, or Barton deoxygenation reaction in which alcohol converted into alkane, or Barton reaction in which alcohol converted into oxide. In this case, vinyl sulfone or nitroalkene react with α-cyanoester in the presence of base to produce pyrrole. So what will be the reaction mechanism for this reaction? Let's have a look to the resonating structure of α-cyanoester. This is the resonating structure of α-cyanoester. When this pi bond shift towards nitrogen atom, so the nitrogen will be neutral in this case and carbene is produced. Whenever electron withdrawing group is present, so the alpha hydrogen atom becomes acidic. We already talked about this in the Aldol condensation reaction. So this alpha hydrogen atom becomes acidic in nature due to the presence of partial positive charge. So whenever base is present in the reaction mixture, base will attract this proton or this hydrogen atom and the bond will be break towards carbon atom. So carbanion is produced. This is carbanion. And in the next step, whenever there is present Michael acceptor in the reaction mixture, this carbanion will attack at the beta position of Michael acceptor. Let's suppose this is electron withdrawing group. Electron withdrawing group may be carbonylic functionality, nitro group or cyano group or any other electron withdrawing group with positive and with pi bond. So it is alpha carbon and this is beta carbon. So nucleophile will attack at the beta position and the bond will break towards alpha carbon. So it is negative charge species. So this negative charge species will shift its electron toward this position and as a result pi bond will be formed. Here, just like in this case, in case of nitro group, the pi bond, the negative charge species is shifting here and the pi bond is back towards oxygen atoms. So this is type of species will be produced. And in the next step, whenever this oxygen donates its electron towards nitrogen atom, so the pi bond will be break towards carbon atom, so negative charge will be produced on this, just like the previous one, negative charge, oxygen. So here carbene is present, so this negatively charged species will attack and this carbene position and it will be cyclized, so it is cyclization reaction. And in the next step, this proton will shift toward this position. So how this proton will be shifting from first position to third position, this negative charge species will attack on this proton because of the presence of this carboxylic ester which make it acidic in nature, and also the presence of electronegative atom like nitrogen. So this hydrogen atom becomes much more acidic. Due to this reason, this carbanion will abstract this proton from that position and negative charge will be appeared at this position. If we talk about this negative charge species, so it is also negative charge species and also negative charge species, so it is also carbanion and it is also carbanion. But if we talk about the stability of this carbanion, so this carbanion is much more stable than this one. Due to this reason, this substrate is shifting towards the right position or from left side towards right side due to the stability of this carbanion. Why this carbanion is stable in the product and not in the reactant? Because here the stability factor is this ester functionality. For this ester functionality, if we talk about ester functionality or any other, let's suppose it is R. So if negative charge species is present here, so it will shift its electron towards the carbonylic carbon and the carbonylic functionality will break pi bond towards oxygen atom, and as a result inlet will be produced. So this inlet and this type of structure, due to their stability, it shifting towards this carbanion position. And in the next step, this negatively charged species will donate its electron towards nitrogen atom, and the pi bond between nitrogen and carbon will break towards this carbon position, and then this carbon position, and then this negative charge will shift towards this carbon position if we talk about a step-by-step mechanism. And in the next step, what will happen, this nitro group will be cleaved in the form of this. So in the next step, through tautomerism, it will be converted into pyrrole. So if we talk about these two structure, it is the same, just different on the basis of this hydrogen atom at this position. It is at first position, and here it is at third position. But this one is much more stable than this one. Due to this reason, it is tautomerized to this position. If you look at this arrows, it is much more towards the right one, and less one in the left side, and less one into the left side. So due to this reason, because of the stability of pyrrole or aromaticity of pyrrole, so the much more product will be in this form. So if you talk about the example of this type of reaction, let's have a look. If we talk about alkene, nitroalkene, so this is nitroalkene. When nitroalkene react with alpha cyanoester, so it is alpha cyanoester. This alpha cyanoester will attack at this position, and then cyclization and much more steps. So it is converted into pyrrole. So it is substituted pyrrole. If we talk about the second example, it is also nitroalkene, and when nitroalkene react with the alpha cyanoester, so it will attack at this position, at the Michael acceptor position, and then the cyclization takes place and aromatization through tautomerism. So this type of pyrrole will be the final product. So it is a substituted pyrrole. I hope you enjoyed the video, and if you have any type of question, you may ask in the comment section. Thank you so much. The Allah Paman.